Hello. If you're watching this video, you've probably been reading my research proposal on the comparison of concrete and virtual manipulatives in math instruction. Specifically, we're looking at algebra tiles, both concrete and virtual, in the context of solving linear equations in grade 8 mathematics. So the purpose of this video is to show you how the concrete and virtual algebra tiles work. So I have my virtual app open here, and I'm going to demonstrate how the concrete manipulatives work, and then I'm going to turn on the full functionality of the app and show you how the virtual manipulative works. So algebra tiles are pieces of plastic, and you can see in the top left-hand corner there are 6 different types. We have our ones, which are small squares, our negative ones, which are red squares. The variable x is a green bar unless it's negative, in which case it's negative x and it's red. So we use these to model expressions and equations, among other things. Now, we're not going to be using x squared or negative x squared in grade 8. Okay? So let's pretend that, I'm just going to get rid of some of these. Let's pretend that I have an equation, and the equation that we're working on is this one right here. 2x plus 3. Actually, I'm going to change that. 2x minus 3 equals 7. Okay, so I'm going to set up my equation. So each of these green bars is an x, so I need 2x, there it is, and I need negative 3, minus 3, so there's 1, 2, 3. So on my left-hand side I've got 2x and negative 3, so 2x minus 3. On my right-hand side I need 7, and those are positive, so 1, 2, 3, 4, 5, 6, 7. There they are. Okay. Now I know that when I'm solving an equation there are certain steps that I need to go through. So the first thing I'm going to do is I'm going to add 3 to each side, because I'm going to try to neutralize this negative 3, and I do that by adding 3. So here I'm going to add 3. There we go. And what I do to the left I do to the right. There. So symbolically the student would write this. 2x minus 3 plus 3 equals 7 plus 3. Okay? Now, at this point, the student would acknowledge that every pair of negatives and positives creates 0 and can be eliminated. So I can get rid of that 0 pair, that 0 pair, and this 0 pair, which leaves me with, I'm just going to move these down a bit, which leaves me with 2x on one side and 10 on the other side. At this point I know that I need to divide by 2 on each side, and with the algebra tiles I would represent this simply by dividing by 2, moving them apart, and then I would have equal groups over here. So an equal group would be 5 here, and the other group would be 5 here, and I would know that x equals 5, and I can see that here, that this x equals this 5 tiles, x equals 5. So that's pretty much how a student might use concrete algebra tiles to model and solve an algebraic equation rather. Now, let's take a look at how it's different when we use the full functionality of this app. So this is the Algebra Tiles app made by Brain Camp. And it's got some features that make the solving of equations much more clear, at least I think so, much more clear to students. So first of all, on the bottom left-hand corner, I'm going to select the equations option, and there I have an equal sign to set up my equation. Now let's take a look at how solving the same equation, there it is, whoops, the same equation looks when we use the full functionality of the app. Okay, so we have 2x minus 3 on one side and 7 on the other side. So let's set it up. I'm going to get my 2x here and my negative 3. Okay, and let's just move that down a bit. Whoops, let's not use the marker. Let's move that out of the way. And Good, let's move that down. Good. Now, over here we're going to have 7. So 1, 2, 3, 4, 5, 6, 7. Okay. So just like before, I'm going to add 3 to each side because I want to deal with that -3. But I'm going to show something down here. The little eyeball at the bottom center, if I click that, it turns on the notation. So I can see the symbolic notation. Now in my proposal, I've been writing a lot about the concrete representational abstract learning sequence in mathematics. And the idea is that Piaget's idea was that students would begin their learning at the concrete stage and progress to an abstract understanding. More recently, people are thinking that those 3 stages can be offered together simultaneously, and one of the benefits of an app like this is that it does that. So with our CRA, concrete representational abstract learning sequence, well, my abstract, the symbolic notation, is right here. This is where we want students to be eventually. We want them to progress to the stage where they can understand an equation, in this case by looking at the abstract notation. However, this app also gives the C and the A, the C and the R rather. In terms of concrete, the child does not have, the student rather, does not have the tactile feel when they are moving the tiles around, but they can manipulate them, which is what they do with concrete manipulatives. They manipulate them. They can actually move them around. And in terms of representational, we do have still pictures of the mathematical concepts when in between manipulations. So an app like this offers all 3. Now let's take a look at how we might solve the equation here, and how it's different when we solve it in the virtual setting. So I'm going to add 3 to each side. Now watch what happens in the notation. Do you see how the notation at the bottom has changed? Every time I add a tile, the notation changes. It was 2x minus 3, and now it's showing 2x plus 3, negative 3. And I know I need to add 3 to the other side, so watch how the notation changes when I add tiles. Okay? Now, when I solved this, pretending these were concrete tiles, I took my 0 pairs and got rid of them, because that's what happens. But when I drag one of these negative tiles on top of a positive tile, they disappear automatically. They make 0 and they go away. So this is a very, very powerful image for students, and of course when they go away, you can see the change in the notation at the bottom. Now I have 2x equals 10. So the notation always equals what I have on the screen in front of me, represented by these tiles. My manipulations create pictures that automatically change the abstract symbolic notation. Very powerful. Okay, now let's just get rid of that circle before we go to the final stage here. Now my next step is I need to divide by 2. So if I go along the bottom here, right beside the I see rows, and right now 1 is selected. I know I need to divide by 2. So if I click 2, so I can put 1x in each of these groups, and then I just need to move equal numbers of 1s into each group. Now I can see that this x is equal to 5, and this x is equal to 5. So I'm able to solve my equation, see it visually in static pictures. I can experience it dynamically in moving tiles, and I have the benefit of the symbolic notation keeping up with these 2 visual representations. So that's just a very quick overview of the difference in concrete algebra tiles and how the same experience can be rendered in the Algebra Tile app by Braining Camp. Thank you.